Welcome to MV Tutors. My name is Fikakahle Manana and I will be doing this paper with you. This is if you look at my screen here, it's the Gauteng prelims preparatory examination. This is paper 2 right now, and this is what we'll be doing right now. We'll start with this question number 1, and if you're ready, I'm ready too. Let's get it. It says Mrs. Molefe decided to research the effectiveness of her online classes. She divided the grade 12 pupils fairly into grade 12A and grade 12B. Grade 12A attended face-to-face classes and grade 12B attended online classes. Both classes were taught by Mrs. Molefe for the same duration. The table below shows the time spent teaching in hours and the average results achieved by the learners in their weekly test as percentages. So as you can see, here's the table right here. Okay, first question, determine the equation of least square regression line of the grade 12s. Okay, so that's 1.1. What we want to do here is get our calculators. We're not going to do it without a calculator. So this is the calculator that you might be having. So here we go. You'll go mode, and then you look for stat, which is number 3. There we go. And we have 2 variables here. Okay, so we'll go for number 2. But before you go for number 2, what I'd like you to do is actually write that equation there, that y is equals to a plus b x, because this is the form that the calculator gives it in, and I know you're used to the other form, standard form, but this is what the calculator does. So anyway, let's go for 2. All right, there's our table right there. So at this point, what I want to do is fill in the table. X will represent the time spent, so let's go for 2 is equals to 8 is equals 4 equals 6 equals 12 equals 10 equals and 11 equals. Now I'll go down once and to the side, and then I'll start putting the y values, which is the average results of 12A. First one is 42 equals 62 equals 48 equals 52 equals 64 equals 63 equals, and then 67 equals. Okay, I got 7 for 7. Cool. Then I can go AC, and what I want to do now is go shift and look for stat, which is number 1 right over here. 1. Now since we're dealing with regression lines, we'll go for number 5, which is regression. So we'll press 5, and then we'll start with A. There we go. So A here was number 1, so we'll press 1 and then equals, and then we get 38.26. I'll leave it in 2 decimal. Okay, and then I'll go AC, shift, stat once again. Regression is number 5, and then we're looking for the value of B, which is number 2. We go B is equals to plus 2.46, because I'm going for 2 decimals. There we go. Now the standard form that you are used to, you can put it if you want, 2.46x plus 38.26. okay, so that's your equation of the regression line right there. Okay, let's go for 1.2 now. It says write down the correlation coefficient of grade 12A results in respect of the time spent teaching. So now the regression correlation rather, we go back to our calculator, and then we go shift once again, we go back to stat, regression number 5, and what we're looking for is the correlation, which is number 3. So we'll go for 3 and press equals, and we get a value of 0.97 because I'm going for 2 decimals. Then 1.3 says comment on the correlation between the time spent teaching and the average results of grade 12A. So it's 1.3. First thing we want to comment about, is it strong or weak, or it's just fair. Remember, correlation is from -1 to +1. Okay, +1 being very strong. Okay, so 1 is like 100%, 0.97, that's like 97%. So this is a very strong correlation, very strong, very strong. And then we want to comment also about, is it positive or negative? If you look at this number, it's positive. So, and positive, very strong and positive correlation. Okay, correlation, there we go. Okay, let's do question 1.4 now. What does it want? 1.4 says the equation of the least squares regression line of grade 12B now is given by that equation. Calculate the difference in the results achieved by each class had Mrs. Molefe spent the average time to complete a particular section. Okay, so it looks like we are comparing class A and class B with the average time spent. So what we want to do then is get the average time spent, and let's go analog this time. Okay, let's really go analog. We're gonna go we'll go 2 plus 8 plus 4 plus 6 plus 12 plus 10 plus 11 divided by 1, 2, 3, 4, 5, 6, 7 data points, and that's going to give us the average time. If I put this in a calculator, I've already put it right here, we get 53/7. Okay, all right, so that's the average time, which is X. Now for grade 12, follow me here. For grade 12A, the formula is y is equals to 2.46x plus 38.26. right? Let's substitute x. So it's 2.46. We'll put 53 there over 7 in brackets plus 38.26. okay, make more space. Okay, and let's put that in a calculator. All right, there's our calculator right there. So we're gonna go 2.46 times 53 divided by 7, and all of that added to 38.26, and we get that. Okay, let me just put it in decimal this time. It's gonna be 56.88, and this is in percentage for grade 12A. Now let's look now at grade 12B, where now the formula is 15.74 plus 4.54x. all right, so 15.74 plus 4.54, and where there's an x we'll put, you guessed it, 53/7. Okay, let's bring out our calculator. This time 15.74 plus 4.54 times 53 divided by 7, and we get an average of 50.11%. Now let's go back to the question. It said calculate the difference in the result achieved. So now the difference, okay, the difference would be the biggest number, which is 56.88, minus the smallest one, which is 50.11. Let's bring out the calculator. So 56.88 minus 50.11, we get a value of, the difference is 6.77%. That's your final answer. Okay. Then the next one says identify an outlier in grade 12B. Okay, that was our final answer right there. So now let's move to 1.5. Outlier is 9%, because it's like it's weird, shouldn't be. And then 1.6, I indicate a valid reason for this outlier. So any logical answer will do it here. You can say something like you know, the learners were still getting used to the online platform on the first week. Okay, that's good enough. The learners were still getting used to the online platform, whatever that platform, or they just couldn't connect at that time. You can say something like it. Now let me say that for this question, for this exam, we don't have the official memo, so we're really just solving these things by ourselves. But if you have another way of doing these questions, please comment in the comment section and let us know how you did these questions. Other than that, that's it for now. I appreciate you. Well, welcome to MV Tutors. My name is Figa Manana, and we are doing the prelims for 2022. We are now on question number 2 of paper number 2, and now this is the Gauteng version, so just know you just wrote this, and we're just doing the memo ourselves. We're not doing it off the official memo. So if you have another way of doing these questions, please let us know on the comment section. Let us share in this knowledge. Okay, but let's read number 2. Question 2. Formula 1 F1 race car drivers. I love F1. I still watch it every week when it's playing. Well, I just watch the highlights, but you know, I watch the game. Have to endure high G forces at extremely high temperatures. They tend to lose close to 4 kgs of weight after every race. 4 kgs. The table shows the total weight loss for 40 different race car drivers after the duration of one race. Now, what I can notice here is that it's given in grams, not kilograms. So it's given in grams. So, and remember, the ratio between a gram and a kilogram is 1:1,000. So that's why you're seeing such big values. Like they said, they lose close to 4 kg, but it only goes up to 3,500 grams, which is 3.5 kg. But anyway, that's just a side note. Then they say write down the modal class of the data. Now, what is the mode? If you remember what a mode is, it's the one that occurs the most, or the one with the highest frequency. Okay, so which one has the highest frequency? It is 2500 to 3000, because it has a frequency of 15 drivers. So let's put it like that. We're gonna say 2500. We'll put it exactly like it's given there. Okay, to 3000. Good. 2. Oh, it's still 2.1. My bad. It's 2.1.2. So this was 1.1. And then it says calculate the estimated mean weight loss of the race car drivers. Now, there are many ways we could do this, but my preferred one is letting the calculator determine it. But first, before I put it in the calculator, I'm gonna need to get the average for each one of the weight intervals. So from 0 to 500, the average there is 250. Let me just change color. Let's go purple. Cool. So it's 250. The next one, between 500 and 1000, that's 750. The next one will be 1250. The next one will be 1750. The next one is 2250. The next one is 2750. And then in between 3000 and 3.5, that's 3250. Okay, and so that's what I want to put in the calculator, versus, let me just put the modes, the frequencies. That's 1, that's 2, that's 3, that's 8, that's 6, that's 15, and then that's 5. Let's bring out our calculator. Okay, so now the first thing that you want to make sure of with your calculator is that you switch on your frequency. Okay, so to switch on the frequency, you go shift, mode, and then you go down once, and then there's stats, there's number 4. So you go number 4, there's your frequency. If you want it on, yes we do, so we press 1. Our frequency is now on. We can check that. We'll go to the table there, and then we go stat. We went mode, so we're in stat now, which is number 3, and it's 1 variable, it's not 2, even though it's a table of 2. The difference is that there's a frequency part now. Okay, and that's what we want to do. So let's put the results. 250 equals 750 equals 1250 equals 1750 equals 2250. 250 equals 2750 equals 3250 equals. So we've got 7 data points. 1, 2, 3, 4, 5, 6, 7. Okay, so we'll go down once, go to the side. Let's put the frequencies now. 1 equals, the next one is 2 equals, that's 3 equals, that's 8 equals, that's 6 equals, that's 15 equals, and then 5 equals 7 for 7. Good. Then we can go AC. What are we looking for? The mean. So we'll go shift stat is number 1, go 1, and let's go var, variable variance, let's go 4, and the mean is there, it's number 2, so we'll go 2 and equals, and then we get that our mean really is what? 2262.5. It's in what? It's in grams. This is just grams. Okay, I'm happy. Next question is the recording of the weight loss in a second race was made a month later. The amount of weight loss in race 2 was kgrams more than in race 1. Okay, so they lost more than 4. Okay, it is given that the maximum value of the ogive representing race 2 was that, and the graph was grounded at 4 and that. Okay, sketch the ogive cumulative frequency graph representing race 2 in the answer book. Okay, let's try that. Let's see how well we can fare. So I'm just gonna do a rough sketch if you don't mind. Okay, it's not gonna be too fancy, so I'm just gonna put in that and that real quickly, and then what I want to do then is name this. I'll put my frequency, and it's cumulative. So cumulative frequency goes this side, and what goes there it's gonna be the weight. Okay, and we know that the standard shape of a cumulative frequency is that it's like an S, like that, and then it plateaus right over there. Okay, and now they've told us that it's grounded at 4 and 0, and then the maximum right there is 3504 and 40. Okay, so those are the important information that you need for this graph. I think that's it. Okay, what's the next question? How will the range of race 2 compare with the range of race 1? Now, if you think of a range is the y values. Okay, is it changing if you look at this range? Well, if I look at this range, really what I'm seeing here is that the range is not changing at all, because it's still gonna be 40. Remember, it's 40 over there. It's still gonna be 40 number of races, right? So I'm gonna say the range does not change. Okay, so you can see even here they said it was K was added, but if you look at this, it moved from 0 to 4, and then from 3,500 they also added a 4, because you can see there, and that's on the X, that's the domain, it's not the range. Okay, so just look out for that. Okay, and then it says determine the average weight loss in race 2. Okay, so what was the average weight loss in race 1? It was 2262.5. It was 2262.5. Just change color. Let's go blue. Now doing 2.2.3. So the first one, okay, I'm just gonna say the average weight loss will be then the average of the other one, which was 62.5. Let me just confirm that one last time. Yes, and you can see it shifted by 4, so I'm just gonna add 4 as well there, and it's gonna give me 2266.5 grams. Now I'm not 100% sure about these answers. Like I said, this is just us. It's what I would have done in the exam, but please do comment on the comment section if I made a mistake somewhere. All right, other than that, thank you so much for watching, and I appreciate you. Well, welcome to MV Tutors. My name is Figa Manana, and we are still doing paper 2 of your prelims mathematics. We're now on question number 3. Now, if we look at this question, it says, in the diagram below, A is given it, B is given, C, D are vertices of a parallelogram, A, B, C, D. Good. So now I hope you know the properties of a parallelogram, such that these lines are parallel and the diagonals bisect each other. But anyway, they do tell you here that diagonals AC and BD bisect each other at P. What does that mean? Bisecting each other. Well, we'll get to see that. The angles of inclination of AD and BD are theta and beta, alpha and beta respectively. AD cuts the x-axis at E. There it is. F is a point in the 4th quadrant. I see it right over there. Okay, determine the gradient of AB. Okay, so to answer this one, we need the formula for a gradient. I hope you know it by head, but in case you don't, it's this one over here. So it's M is equals to, that's it, y2 minus y1 over x2 minus x1. Okay, so let's go back to that question. It was question number 3.1. So 3.1, let's go. Gradient of BC. So I'm gonna make B, there it is, and C, there it is. I'm gonna make B2 and C1 such that the gradient of BC will be given by y2, which is B. It's going to be 8, y1, C, 0 divided by x2 is 4 minus 5. And we get 8 over minus 1, so really it's just minus 8. Okay, that's the gradient. If the distance between A and B is 65 square rooted, calculate the value of that. Okay, that's cool. We can do that. Let's gem that real quickly. Let's go orange. So this is now 3.2. We need the distance formula. Okay, and the distance formula says that the distance from we're looking at distance from A to B. That's given by, well, if you don't know it by head, once again, it's there in your formula sheet. There it is, the square root of x2 minus xy, x1. So we're gonna go x2 minus x1 squared plus y2 minus y1 squared. Now there's a square root, but what I want to do is take out the square root by squaring both sides such that it's that squared. Okay, just took out the square roots, that's all I did. So that now I'm gonna have a square root of 65 squared is equals to I'm gonna make which one am I gonna make? B. I'll make it 2, so that it's gonna be 4 minus 3, which is plus really, plus y2 is gonna be 8 minus k squared, and then this one squared, that's just 65. 4 plus 3, that's 7 squared, plus I really just want to expand this. You know, there is a short way of doing this. When you're in metric, you need to be able to do that, because it's gonna save you some time, but for the purposes of this video I'm doing it the long way. So it's 8 times 8, which is 64. 8 times minus k is minus 8k, minus k times 8 is minus 8k plus k squared. Now I want to put everything into one side. Let's just get some more space right over there. So I'm going to leave a 0 this side. It's equals to 7 squared minus 65. Okay, plus 64 minus 8. Minus 8 is minus 16k plus k squared. Now what I want to do is just put this in a calculator real quick. I was doing question 2, so I had that mode on still. So I'm gonna say 7 squared minus 65 plus 64, and I get 48. Okay, so now it's gonna be k squared minus 16k plus 48. Okay, now I need to be able to solve for k. So what I'm gonna do here is that I'm gonna open 2 brackets, right? Both of them have k. Now I'm gonna look for a number multiples of 48 that when I add them up will give me 16. So I'm thinking 12 and 4 times 12 is 48. Now 12 plus 4 is 16, but it's a negative 16, so which means they both have to be negative. So now k is equals to 12 or k is equals to 4. Now only one of them can be correct, not both. So I'll come back to the if we look at this diagram over here, we can see that the value a is minus 3, and that's k. Now that k value has to be less than 8 because it's at the bottom, because if it was 12, then it would be up there, which is not gonna be correct, which means k can only be 4. So what are we gonna do? We're gonna come back here and then we're gonna say k cannot be 12. Therefore k is just equals to 4. All right, hope it's clear. Okay, next question says prove using analytical geometry methods that BP is parallel AC. Now for parallel lines, we know that actually we know, let me change the color there. So now this is for 3.3. We know that m1 times m2 must be equals to -1. These are the gradients. Okay, if you multiply two gradients, they give you -1, then those lines are parallel. Are perpendicular to each other. Okay, BP. So BP is, if I'm to just to redraw this, I got B there and I got P there, and then AC, A is right there and C is there. Okay, cool. So what I need to do is just solve the gradient. So, but first of all, I need to get the point P. Now that's the midpoint. Okay, and to calculate the mid points, let's just go check it out on the formula sheet once again. It's there. Where is it? There it is. So we're gonna have, we have that the midpoint is given by x1 plus x2 divided by 2 is to y1 plus y2 divided by 2. Just like that. Okay, now let's go back to the question, because that's what we're working on. Let's start putting some numbers now. Okay, so for the midpoint P, I'm gonna use D and B to get the midpoint. So I'm gonna make D1 and B2, so such that x1 is gonna be -2 plus 4 divided by 2, and the y value is gonna be -4 plus 8 divided by 2. Okay, what's 4 minus 2? That's 2. 2 divided by 2 is 1. And then -4 plus 8 is +4, or 8 minus 4 is 4, divided by 2 is 2. So the point P then, this is point P, is 1 and 2. Now that I have this point P, what I can do is then solve the gradients. Okay, so let's start with the gradient of PB. Right, remember it's y2 minus y1. B will be 2, so it's gonna be 8 minus 2 right over there, divided by, it's gonna be 4 minus 1, such that I have 6 over 3, and that's a +2 gradient. And now I need the gradient of PC. Okay, PC, and it's gonna be 0 minus 2 divided by 5 minus 1. Okay, so this is gonna be a -2 divided by 4, which gives you a -1/2. Now, if you look at these, if I multiply these, if I say gradient of PB multiply by the gradient of, let me just call it AC, because PC and AC are the same. They have the same gradient. I'm using AC because that's what we're trying to prove. And then that's equals to 2 times negative a half, which is equals to -1. Therefore, we can now conclude that BP is perpendicular to AC. Nice. We are done with this question. Let's check the next one, which is 3.3. Prove using analytical. Oh, no, that's what we're doing now. So I guess we're moving to 3.4. Calculate the coordinates of F if it is given that ACF is a parallelogram. Okay, let's change the color. So now we are on 3.4. So we and it's 2 marks. So we have a shape that's like this. Okay, if we look at the shape, I'm just gonna try to redraw it. It's really like this. Okay, it's really like that. Such that that's B, that's A, C, and that's D. So now if we look, and we want, it's ACD, and actually what we are looking for is ACFD. ACFD. So now the shape that we are looking for, ACF, so F is somewhere there, AD, no, ACFD, ACFD, AC, I'm just trying to get the drawing right, you know, it's AC, so the one that we're looking for is like this, AC, F is down there, it's on that quadrant, let's say, ACF, and then D right there. Okay, it's not to scale, but I guess you see the picture that I'm trying to draw there. Let me use a different color. Okay, so it's like this, AC, and then F, yeah, well, my drawing doesn't look so good, it's a little bit long, but anyway, you get the point. F is gonna be there. So what we're gonna do, since it's a parallelogram as well, we know that from A to D, we know that A has the coordinates of, what are the coordinates of A? It's -3 and 4. We solved it. So how did we move from -3 and 4 to D, which is -2 and -4? Because that's gonna give us the coordinate of F from C. C is 5 and 0. Okay, so from -3 to, if we're looking at the X, from -3 to -1, that's a positive step to the right. That's 1 unit to the right, from -3 to -2. So which means we must take 1 unit to the right here as well, from C to F, and it's 5 plus 1, which is 6. And then from 4 to -4, that's 8 units. Okay, because it's 4 minus -4, which is +8, which means we must subtract 8 from C to F as well. So it's going to be 0 minus 8, which just gives you -8, like that. So that's our coordinate of F is now 6 and -8. Okay, and then 3.5 says calculate the size of EDO. Okay, let me change that color once again. We're looking for the size of EDO. Okay, so that's now 3.5. Okay, EDO, let's just draw it. Where is E? Okay, so it's like ED is like that, and then from there to O, it's like that. So EDO. So we got E right here, we got D, and then O, shaped like that. We want the size of it. Okay, so what I'm gonna do here, so watch closely what happens here. I'm going to draw a parallel line to the x-axis. Okay, that's the x-axis right there, and I know that this from ED, it has we've been told that's alpha. Okay, but DO, that's beta, this one. So to get EDO, we have to subtract beta from alpha. As you can see, big angle from smaller angle. So we need to solve these angles basically. So what do we know how to solve these angles? We know that we know that gradient is also equals to tan whatever angle it is. Let's call it theta because that's what it says in the formula sheet. So for the purposes of this one, we're gonna say DO. Let's start with beta, DO. Do we know the gradient of DO? DO, same gradient as BP. I think we solved it. It's either 2 or -2. PB, the gradient of PB, it's the same gradient. DO and PB are the same, so that's the one of -2. I mean of +2. So what can we do with that information? We're just gonna bring it back here. We're gonna say, okay, so for a gradient of 2, we know that that's gonna be tan beta, right? And then to get beta, we're gonna have to say tan arctan, put a 2 there. Let's put that in a calculator and let's see what we get. Okay, so we're gonna go shift 10, put a 2, close the bracket, equal. So that's 63.43. 63.43. Okay, let's go for alpha then. Alpha, for alpha, that's the gradient of AD, which is a gradient of DE. Did we solve the gradient of DE or AD? Let's go check. Let's go check. This is PC. It's not the same gradient. PC, It's not the same gradient as AD or E or ED. So, but what about the first one that we solved? Remember the first one, this one? It was the gradient of BC. The gradient of BC, since this is a parallelogram, is the same as the gradient of AD, or the same as the gradient of ED. So that's going to be a -8 gradient. Okay, I hope you can see that. Those are just properties of a parallelogram. Okay, so now we know that -8 is equals to the tan of alpha. And then to solve alpha, then it's going to be tan, or the arctan of, well, there's two ways of doing this. So let's put the -8. Either I put a -8 there or a +1. It's going to be pretty much slight differences rather, but it's pretty much the same. -8. If I put a -8, I'll show you what that does. It gives us a negative answer, and if it gives us a negative answer, all that means is that to get, because -82 is on the 4th quadrant, and that's not the gradient we're looking for. Okay, it's on the 4th quadrant, but we're working with the 2nd quadrant. Okay, ED is on the 2nd quadrant, so all we have to do is add 180. Okay, so we're going to say plus 180, and that's the actual answer of it, 97.13. Okay, so from there we can then conclude now that the angle EDO is going to be equals to alpha minus beta. Okay, because you can see from our diagram here, it's alpha, which is the big angle, minus beta, which is the smaller angle. Okay, so let's put that in a calculator. Oh, rather, let's write it down first. It's 97.13 minus beta, which is 63.43. Okay, we can bring out the calculator now. Ooh, let me just say answer minus 63.43, and I get 33. Okay, they said something about decimal places, 1 decimal place. So what's 1 decimal place here? 0.7, and that's in degrees. Okay, so that's our EDO angle. All right, let's move on to the next question. 3.6 is the last one. Calculate the area of ADC. Okay, so I like to always isolate the drawings, or rather the shapes that I'm working with. So I'm gonna redraw ADC. ADC. So really, it's this one. It looks like AD, and it's like that, and then C is right over there, and A is just like that. Cool. So that's A, that's D, and that's C. Okay, so how can I do this? Okay, so I can get the distance, because the formula for this, if you remember correctly, the formula is that actually let's go grab the formula from the formula sheet, because there's something I want to show you. So the formula of an area of a triangle that we're working towards is that it is half AB sine C. So it's an inclusive angle, meaning, for example, if we're going to use the angle of A, we have to use this distance of AC, okay, which is small d, and this distance of AD, which is small c. Okay, let's see, can we get this angle of A? What do we know? So far, if we look at that triangle, if we look at triangle ADP, it's a smallish triangle like this. So that's A, that's D, and then that's P. What do we know? We know that D is 33.7. We just solved it. What do we know about angle P? We know that the angle P is 90 degrees. So we can get the angle of A using some of angles. Okay, so that's gonna be A is gonna be equals to 180 minus 33.7, because remember we got 33.7 up there, minus 90, because that angle, that bisector there, we solved it even, it's 90. When we were proving that perpendicular means 90 degrees, minus 33.7 minus 90. So, I don't want that. So our angle is then 56.3. That's our angle A, right? Now we need the distance. We need the distance AC, and if you remember the distance formula, we used it in one of these questions here. I think it was the second one. It could have been easier if I just this one, x1, and this formula over here, that's the one that we are going to be using for distance. Okay, so just follow me here. Let's start with the distance of C, small letter C. Okay, so that's gonna be equals to the square root x1, that's A, between A and D. The x is minus 3 for A, minus for B, for D, it's minus 2, which is a plus. That should be squared, plus the y's. Remember we solved k to be 4, so it's 4 minus 4 squared. Okay, that's gonna give us the value of small letter c there. Let's just put that in a calculator. So we have minus 3 plus 2, it's gonna be squared, plus 4 minus 8 squared. Okay, so C is the square root of 65. Cool. And then the small letter D, we use the same formula. Let's just see the numbers we're working with. AC. So AC, so we're gonna say A once again is minus 3 minus, for C it's 5. It's gonna be squared plus, and then it was 4 minus 0 squared. Put that under the square root. Let's get the calculator once again. Square root of negative 3 minus 5, close that, squared plus 4 squared, and I get, is it supposed to be 4? No, I think I do. Yeah, because it's 4 minus 0. Oh yeah, 16. 4 squared. Let's try that in decimal. Ooh, doesn't look good. So did I write this correctly? It's the distance of AC. It's minus 3 minus 5, and then it's 4 minus 0. Okay, it's it looks okay, so I'm gonna stick with this. I'm gonna stick with that. Let's just do it. It's 4 square root of 5. Ladies and gentlemen, I'm doing this myself, so I'm not sure if my answers are correct or not. Please check as we go together. Okay, so if then that's the case, ADC. Okay, it's the right triangle. Okay, so if we go back here, we have the value of C, we have the value of D, and we have the angle. So we just need to put them together now. Okay, so there's the angle. So our area will then be given area of triangle ADC will then be given by a half CD and sine of A. Okay, we have the numbers. It's a half. C is times square root of 65 times D is 4 square root of 5 times sine of A, which is 56.3. Okay, so let's put that in a calculator. And it's going to be 0.5 for the half times square root of 65, go to the side, times 4 square root of 5, go to the side, times sine of 56.3, close a bracket, and it's equals to 29.9996, so that's like 30. And since we're dealing with area, unit squared, or square units, units squared. Okay, that's it. Well, thank you so much for doing this with me. I appreciate your participation and you watching. Remember, I appreciate you. Goodbye. Well, welcome to MV Tutors. My name is Figa Manana, and we are still doing paper number 2 of the prelims of this year, 2022. These are the Gauteng prelims for mathematics. Okay, question number 4. Here we go. Let's get into it right now. It says, in the diagram below, the equation of the circle with center is that QT is tangent. There's QT. There we go. To the circle at T. I see that. TNP is a diameter. TNP. Oh, great. Of the circle. Point P is 5 and 4. Nice. Lies on the circle. Nice. Okay, first question. Write the equation of the circle in the form. Okay, that form. So what we want to do first is just write it in the form. I'm just gonna rearrange it so that the x's are alone. So it's minus 4x there, and then it's plus y squared minus 2y, right? And then what I want to do is bring the 13 to the other side. When it comes to the other side, it's a positive 13. Cool. What that does is that it now allows me to complete the square. Okay, so if you remember how to do this, all I'm gonna do is just I'm gonna add a bracket. I'll put that number there, which is 4, always divided by 2. The coefficient of the x always divided by 2, and then squared. Okay, I'll do the same for the y values. Minus 2y, and then I'm gonna open a bracket. I take the coefficient of y. It doesn't matter whether it's negative or not, because anything squared is going to be positive anyway. Okay, equals to 13. Then what I want to do is add, what's 4 divided by 2? 4 divided by 2 is 2. 2 squared is 4. So add a 4 here. I'm adding the brackets to anything I do on one side, I must do on the other side. Okay, so if that's what I'm doing this side, that's what I'm doing on the other side. 2 divided by 2 is 1. 1 squared is still 1. So there we go. And then what this allows me to do is that from this I'm taking the x. From the second one I'm taking the sign, which is negative. And then from this one I'm just taking what's inside the brackets, which is 4 divided by 2. That's 2. And it's squared. Plus, from the y squared, I'm just taking 1y. From this minus 2y, I'm just taking the sign, which is negative. From this bracket, I'm only taking what's inside the bracket, which is 1. Okay, that's gonna be equals to 13 plus 4 plus 1. That's 18. Okay. This is squared. Okay, so that's it. That's it. It's already in that form. Okay, so let's go now for 4.2. It says write down the coordinates of n and the length of nt. 2 marks. Yo, for so much work. Wow. Okay, let's change the color. Let's go black this time. So what do we have here? We have a circle, right? And then we have n right there. That's the coordinates of n. That's n. Okay, and then t is right over there. Cool. So now the coordinates of n, we just read it off from this form that we've put it in. So it's just going simply 2 and 1. And the length we need the distance formula. If we remember the distance formula, square root of x2 and x1. Oh, I have coordinates of n. Okay. Oh yeah, but I can use the coordinates of p, so it's gonna be x1 minus x2 squared. So p is gonna be 1, so I'm gonna have 5 minus 2, okay, squared, plus on the y side it's y2, which is 4, minus y1, which is 1 squared. All of this under square root. Let me bring out a calculator. Oh, this was from the previous question. Square root 5 minus 2, that's 3, so we've got 3 squared, plus 4 minus 1, still 3, so we've got 3 squared as well. It's 3 square root of 2. 3 square root of 2. Now, ladies and gentlemen, I have no memo for this, so I'm just doing it by my head. So if I make a mistake somewhere, please just write it on the comment section so that we can correct this together. Okay, so therefore the length of nt is equals to 3 square root of 2, because np and nt have the same length, right? Correct. Okay, let's go then for the next question. Okay, so the next question will be 4.3. Determine the equation of the tangent QT in the form. Okay, so for the tangent, first of all, we need the gradient. Okay, I think that will be easier to calculate. We'll also use NP once again to represent, because it's the same as NT, right? So we're gonna go 4.3. So I'm saying let's solve for M first. The gradient of NT. Remember, the gradient of NT is the same as the gradient of NP. So we'll use coordinates of P. And if you remember the equation of gradient, it's y1 minus y2 over x2 over x1 minus x2. Or you can interchange those numbers, but we're gonna make it p. 2 will be p and 1 will be n. So we will have, let me just remove this so that you can see, p is 5, or y, so it's gonna be 4 minus 1 divided by 5 minus 2. What's this? 4 minus 1 is 3, divided by 5 minus 2 is still 3, so the gradient is 1. And we know that the tangent is always perpendicular to the radius, so m1 times m2 is equals to minus 1. Remember that, which means the gradient of perpendicular lines, if you multiply them, they equal to minus 1. Now we have the gradient of nt, which is 1. Now we want the gradient of qt. Okay, let's say qt. So the gradient of qt then it's just simply gonna be minus 1. All right. Okay, so let's move on swiftly. Now we need the point T. Okay, so if I have the circle like that, and I have that point N, and I know it's 2 and 1, and P, I know P to be 5 and 4, right? In order for me to get the point T right here, I can use my eyes or a simple calculation. How many units is it from 5 to 2? It's 3 units, isn't it? 5 minus 2 is 3. So to get to T on the X, I also have to do the same and say 2 minus 3. 2 minus 3 is minus 1. And on the Y, it's 4 to 1. So 4 minus 1 is 3. So I need to say 1 minus 3, which is minus 2. There we go. So now what that allows me to do is mx plus c. Okay, value of m, we've solved it to be minus 1, so I have minus x, plus c. I need to solve c, so I need a point where this graph passes, and I've just solved it. It's minus 1 and minus 2. Okay, so we just need to substitute those in the equation, x and y. So I'll have minus 2 there is equals to minus 1, like that, plus c. And then if I do that, this is going to be positive 1. If I take it to the other side, it becomes negative, and then my final answer is negative 3. So then equation of qt is given by y is equals to minus x minus 3. That's it. Okay, there we go. Let's go to the next question. It says the circle with center S touches the circle with center N externally at T. QT is a tangent to both these circles. If NS is equals to 3NT, determine the coordinates of S. Okay, so first of all, I need to draw what's happening here. Okay, and it's like this. We have this circle here. What's going on here? We have this circle, and then we have because it says NS is 3 times NT, which means the other circle will be twice as big. Yeah, or rather, it has its radius is much bigger. Okay, remember they are actually sharing a tangent, which is QT, and the tangent goes right there. Okay, so now what that is that we have that point, and that's point T, and that's point N. So that's NT, and then here is a center, which is S there. So they are saying NS, which is the entire line, is 3 times NT. Okay, but now if I want to make a ratio between NT is to T TS, so which is radius to radius. If NT is 1, TS is gonna be 2 or 3? It's gonna be 2, because remember it's NS that is times 3, but TS is times 2. Okay, I hope you're able to make that difference. So let's look at the X values. What happens to the X values? So remember, from N to T, we said we're subtracting 3, if you remember, which means for TS we have to subtract twice as much, which is minus 6. For the Y, from N to T, we have to subtract 3 as well, which means for TS we have to subtract minus 6. What does this help us? It helps us here. Okay, it helps us to determine S, because now what we can do is that on the X, remember T is the coordinate of T is, we solved it, I think it was, let's just check it, -1, -2. So -1 and -2. So from -1 we have to go we have to subtract -6. So -1 -6 is -7, and then from -2 we have to subtract -6 again. We have to subtract 6. So -2 -6 is gonna be -8, is it? So that is the coordinate of S. Determine the coordinates of S. That's it. Okay, like I said, I'm just doing what I think is the solution here. If you have a better way of calculating these things, there are always other methods, or if you've seen I made a mistake, please write it down on the comment section. Let us help each other. Otherwise, that's it from me. I do appreciate you. Goodbye.
Hello everyone and welcome to MB Tutors. I'm Tulu, and as I was reading comments, thank you so much for your comments for question 4. So someone commented that, the way in which my husband did 4.4 was quite quick, and maybe they won't give him, or if he were to write, the 7 marks won't be rewarded. Especially with the information given, they probably would have wanted you to solve it simultaneously. And then I responded that I will actually do this the long way, because you know me, I like doing things the long way. I just look for shortcuts, which is good because you need to save time. But if I see 7 marks, I know there is some amount of work that they require. But anyway, let's look at it. So it says, the circle with center S touches the circle with center N externally at T. QT is a tangent to both these circles. And remember, QT had a gradient of -1, right? Meaning NT had a gradient of 1. And then it says, if NS is equal to 3NT, determine the coordinates of S. So NT, which is the radius, remember the radius squared was 18. So NT is √18. And and now to get to S, NS would be 3NT. So you get √18, another √18, another √18. So basically that's where S is. And this basically TS is like the radius. So this is quite a big circle. Okay, so if this is the center of the circle, we're looking at a huge circle there. Okay, so for the purpose of this question, I'm just going to illustrate is being part of, center of a circle. So this is not really the size. I haven't drawn this to scale. Please don't take this as it being drawn to scale. But basically, NS, which is this whole length over here, that is equal to 3 times nt, and we know nt is root 18, so 3 times root 18. Okay, and then we know that from the center of a circle to the circumference, it is at 90 degrees to a tangent line. So we also know that the gradient here would be 1. So how are we going to determine the coordinates of S? Okay, how are we going to get A and B? Let's see, we have 2 unknowns, so we're going to need 2 equations. The first question, I'm going to use the distance formula, okay? So basically, the distance of TS, okay? So TS squared would be the value of x for t and the value of x for y. What did I say? The value of x for s, okay? And that is squared, and the same thing, ty minus sy squared. All right, so now ts, we know it would be twice root 18, okay? And then the x coordinate, so t, I think we had it as -1 and -2. Or was it the other way around? Yeah. All right, so the x value for t is -1. The x value for s is a. Then the y value for t is -2. The y value for s is b. Okay. And then this is also just squared. All right, and then if we calculate that, so we're gonna get 2 root 18. Okay, if we square that, we get 72. And then now we're just gonna solve here. So I'm gonna start with a squared. Actually, let me put it like this because it looks like now. Okay. So a squared, and then -1 times -a, that's positive a. So I'm gonna have 2a, and then plus 1, and we're gonna add b squared. 2 times b is 2b, and then times 2, that's 4b, and then plus 4. All right, so I have here, if I simplify it further, I have a squared plus 2a plus b squared plus 4b plus 5. Okay, 72 minus 5. Let's see. So that is 67. So 67 is equal to a squared plus 2a plus b squared plus 4b. Okay, and that is equation 1 for me. Now, how am I going to get the second equation? Well, I know that the equation, or rather, the equation for line TS, I know the gradient is 1, all right, and then I know a point T. Okay, so y is equal to mx plus c. The point T, my y is -2, my gradient is 1, x is -1, okay, plus c. So c would be equal to -2 plus 1, which is -1. So then my equation would be y is equal to y is equal to x minus 1. Okay, y is equal to x minus 1. And if I write that in terms of a and b, I would have that b is equal to a minus 1, and that's my second equation. Okay, now I can go and substitute b, or rather substitute 2 in 1. Now I need to remember. Okay, so 67 a squared plus 2a plus b, which is a minus 1 squared, plus 4a minus 1. This is long, guys. What my husband did is quite straightforward and easy. But we'll see when the memo comes out if they really, they're fine with it. Okay, if we expand this, let me try to be quick. A squared minus 2a plus 1, 4a minus 4. Okay, a squared plus a squared, that's 2a squared. 2a minus 2a, they cancel, but I have 4a. And then 1 minus 4 is minus 3. If I take minus 3 to the other side, or if I take 67 this side, I'm going to get negative 70. Okay, and then at this point, you use the quadratic formula. Okay, let's just say you use the quadratic formula. I'm going to go and use this very smart calculator because of time. And then I'm just going to substitute the values so that I can get what a is. Okay, so a can be equal to 5, or a can be equal to negative 7. Okay, looking at where s is, which is somewhere over here, like the way we drew it, we know that s has to be negative, right? The a value, that is, or the x value. So it can't be equal to 5. It's going to be equal to negative 7. And then we know that b is equal to a. Okay, b is equal to a minus 1. And a is negative 7 minus 1. So it's negative 8. Okay, therefore the coordinates of s are negative 7 and negative 8. Okay, and I guess that's it. Thank you for tuning in. We always look forward to your comments, your, I don't know, expertise at times. My English is failing. But yeah, please do comment below if you have a shorter way of solving it. By all means, share with other students. But yeah, that's it from me. Don't forget to share, don't forget to like our videos, and also subscribe to our channel. Hello everyone, and welcome to MV Tutors. My name is Zulu, and I'll be looking at question 5 with you guys. Please don't forget to like our videos and subscribe to our channel, and please share with your classmates this information, right? If you do recognize any error made, thank you for those who do comment and give alternatives to answers. We really appreciate it. Let's keep the conversation going. Correct us where we make mistakes, whether silly or just hectic. Please correct us. We're here to learn, and we're here to impart knowledge, but also learn from you guys. Okay, so yeah, question 5. Let's get to it. In the diagram below, point P, we have the x coordinate of negative 3 and a y coordinate of negative 3 root 3, and reflex angle 2 theta are shown. All right, it's one of those questions you will always expect them. Sometimes, yeah, I get a little bit dribbled by them, but we are here. Okay, so it says determine without the use of a calculator the value of cos 2 theta. So this is this is 2 theta, all right? If we just complete this triangle over here, we'd know that this would be the negative 3, and that would be negative 3 root 3, right? The y value, and that would be our cos 2 theta. That starts from the positive x-axis all the way to hypotenuse OP. All right, so before we even begin determining what cos 2 theta is, because we know cos, soc à toi, so cos is adjacent over hypotenuse, we need to work out what the hypotenuse is, okay, which is OP. And in this case, we know that OP squared is equal to negative 3 squared plus negative 3 root 3 squared, right? And then OP would be the root of all of that. So negative 3 squared plus negative 3 root 3 squared. Okay? And if we were to work that out, As you can see, I tried it before. So negative 3 squared plus negative 3 root 3 squared, and our answer is 6. So our hypotenuse, the value of it is 6. Now our triangle is complete and we can answer the following questions confidently. Okay, so cos 2 theta, which would be adjacent over hypotenuse, the adjacent there that we see is minus 3, and our hypotenuse is 6. So therefore our answer is negative a half. Okay, now we get to the next question, 5.1.2, where we need to calculate sine theta. Okay, so because we have because we have a double angle, we could either choose between sine 2 theta or cos 2 theta. I wouldn't go the sine 2 theta route, because the answer that I would get would be 2 sine theta cos theta. We don't have cos theta and we are looking for sine theta. So yeah, I'd rather go with cos 2 theta and expanding it. Remember, cos 2 theta has 3 options. Rather go with the option where we have only sine in it. Okay, so basically the option where we only have sine in it would be 1 minus 2 sine squared theta, and that's something that you can check in the formula sheet. It's there. All right, so cos 2 theta, we already determined that it's negative a half. If I take this one to the left hand side, I will get negative 1, and then I have negative 2 sine squared theta. If I multiply by negative throughout, I will have a half plus 1, and that is basically 1.5. Okay, and the side, because we multiplied by negative throughout, it applies on the left hand side as well as the right hand side. Now if I divide by 2 both sides, I will end up having 3 over 4 is equal to sine squared theta. All right, now if I were to get sine theta, I would have to root 3 over 4. Okay, and generally you would say plus or minus. Okay, but because we are dealing with the third quadrant, sine is negative in the third quadrant, so basically your answer would be the negative root 3 over 4. And now we can go over to 5.2. Excuse me. So we have cos squared 180 plus x. I'm going to write it like this, 180 plus x. And I do this because sometimes we can make errors. Like we know that 180 plus x is in the third quadrant and cos is negative, and we put the negative outside, forgetting that the whole expression is squared. So I prefer putting it this way. Okay, and then we have plus cos negative x, tan x times tan x, okay, times cos 90 plus x. Okay, now yes, cos 180 plus x, like I said, is in the third quadrant, so cos is negative in the third quadrant, so we're just going to have negative cos x. But remember, there is a squared on top there. Then cos of a negative angle, remember sine and tan of negative angles, they equal to negative sine, negative tan, but cos is quite different. Okay, cos of a negative angle is actually equal to a positive angle. And if you were to draw the cos graph, basically it would do that over a period of 360 on the positive side of the x-axis. And it also does the same thing on the negative side of the x-axis. So it reflects about the y-axis, and that is why if you were to get cos of a negative angle, it's pretty much equal to cos of the positive angle. And then with tan, I would rather use the identity sine x over cos x, and then multiplied by Again, if you have your Cartesian plane, this is 90, that's 180. So we have cos 90 plus x. So 90 plus x, we land in the second quadrant where only sign is positive. So because we have cos there, we're going to have a negative, okay? And then the cos in the 90 plus x turns it into a sine x. Okay, your co-ratios, basically. Okay, now we can simplify further. So negative cos x squared is basically going to be cos squared x. And then here the cos's cancel. We have sine x times negative sine x, which will be negative sine squared x. And once you get here, I mean, the temptation here is to think of the identity where we have cos squared x plus sine squared x is equal to 1. So in this case, we have a negative, okay? And I hope when you see a negative, you get reminded as that one of the options of cos 2 or cos of a double angle is you get cos squared of an angle minus sine squared of an angle. Okay, there it is. I hope you can see my cursor. So at the end, we're going to have cos 2x. Okay, and that is basically it with number 5.2. Let me just make sure before we move on. And yeah, that's basically it. Now 5.3.1. So consider the equation. So what is the equation? 5 tan theta minus 6 cos theta is equal to 0. So consider the equation and show that it can be rewritten as 6 sine squared plus 5 sine theta minus 6. I think let me just make this a bit bigger. Yeah, okay. So let's see, let's just see how far we can go. So because I don't see any tan here, I only see sine, I will be turning this tan into sine theta over cos theta. Alright, and then I have there 6 cos theta is equal to 0. Because I don't like working with fractions, I'm going to multiply by cos throughout. So I'm left there with 5 sine theta, and I see 5 sine theta in the answer. So I know I'm headed in the right direction, and I have 6 cos squared theta is equal to 0. Now, again, I don't see any cos in my final answer, so I'm going to go back to my identity. Remember, we know that sine squared theta plus cos squared theta is equal to 1. If I were to write cos squared theta in terms of sine, it will be my 1 minus sine squared theta. So that's what I'm going to do here. So I have 5 sine theta minus 6. This cos squared theta can be written as 1 minus sine squared theta equal to 0. And then we're going to multiply it out. So 5 sine theta minus 6 plus 6 sine squared theta. Alrighty, do we have everything there? 6 sine squared theta, 5 sine, yep. So I'm just going to rewrite it the way they put it for us. So I have 6 sine squared theta plus 5 sine theta minus 6 is equal to 0. And that was how many marks? I think it was 3. Yep. Now, second question, it says, determine the general solution of 5 tan theta minus 6 cos theta. Okay, so we already know what 5 tan theta minus 6 cos theta is, right? We just simplified it as they said it. So I don't know if you can see here. So 5 tan theta minus 6 cos theta is 6 sine squared theta plus 5 sine theta minus 6. So I see here and I recognize that I have a quadratic formula, okay? And because of that, if this is a bit too difficult for you to comprehend, because I know some people struggle with using all these trigonometric expressions, if it's a bit of a struggle, just say sine theta is equal to x. And therefore you have 6x squared plus 5x minus 6. Then it becomes a little bit easy, right? And when you get to this point, you can choose. Are you going to use the quadratic formula, or are you simply going to use factors? Okay, so I know to get 6, I will either have 2 times 3 or 5 times 1. I will go with 2 times 3 here. And then what will give me positive 5 and negative 6? So if I were to multiply 3 and 3, I would get 9, right? It's positive, ne? And if I were to multiply 2 and negative 2, I will get minus 4. So positive 9 minus 4 will give me positive 5. So I will go with that solution. Okay. All right, equal to 0. So now I know that 2x plus 3 is actually, at this point in time, I can just say 2x is equal to negative 3, or 3x is equal to 2. Remember, we're not dealing with x here. This is where I'm going to bring back my sign. Okay, let me just solve for x. Minus 3 over 2, 2 over 3. So I go back, sine theta is equal to negative 3 over 2, or sine theta is equal to 2 over 3. And remember, guys, when you solve for x or theta or sine theta or whatever it is, y, it's preferred that you go and check your answer. So I don't know if you guys are allowed to use this calculator, but I'm going to check it quickly. Okay, so you go to mode, setup, and 5 equation. We have a quadratic equation, so we'll choose 3. Then the coefficient of x squared there was 6, the coefficient of x 5, and then our c value negative 6. So we see our answer 2 over 3, yes, and the second answer negative 3 over 2. Awesome. Okay, so we've checked, but obviously you're going to check the long way if you don't have this calculator. Now we can work out the general solution, but guys, sine theta is equal to negative 3 over 2. If you try to work out the angle, you will see that actually it's a math error. And why is that? Sine starts at 0, its maximum is 1. Okay, it does this. Okay, on the negative side, it does that. All right, so negative 3 over 2 is negative 1.5. Sine does not reach negative 1.5. It's maximum and minimum. Maximum is 1, minimum is negative 1. I'm not wearing my ring. Anyway, yes, maximum is 1, minimum is negative 1. There is no negative 1.5, so you're going to get a math error. And let me show you. So we have negative 3 over 2. So as soon as you get an answer above 1 or below negative 1, you're going to get a math error. Okay, so this doesn't work. All right, so I can just get to this point here and say sine is not equal to that. But if I solve it this side, theta will be equal to 2 over 3 is a fraction, and it is in between negative 1 and 1. So that one we can be sure, be confident that we will get an answer. Okay, so 2 over 3. And we get 41,81 degrees. Okay, so we have our reference angle. Now we have a look. Where is sine positive? Sine is positive in the first and the second quadrant, right? So this is where we now get our general solution. General sol. General solution. So in the first quadrant, quadrant 1, I will say our reference angle. So our reference angle is 41,81, okay, plus 360. Remember the period of the sine graph is 360 times k, where k, this is very important. Do not forget that k is an element of integers. Okay, it can't be a fraction. It has to be a full number that can be negative or positive. Okay, so that's the general solution for the first quadrant. Now the general solution for the second quadrant, Maybe I should just say quad 1 and quad 2, because now it looks like question 1 and question 2. So quadrant 1, quadrant 2. So we know in quadrant 2 that we have 180 minus the reference angle. Okay, and again, plus 360 degrees, okay, where k is an element of integers, okay? And then we just calculate what is 180 minus 41.81. So it's 138,19, and then plus 360 times k. Okay, so that's your general solution completed. If they were asking for values of theta between a certain domain, then you would substitute the k value 0 or 1 or -1, whatever, but they just want the general solution. So we are done in this case, and that is question 5. Alrighty, now we get to question 5.4. Okay, 5.4, prove that cos 2 alpha, just gonna write all of it down, hopefully it fits, 2 alpha plus 77 degrees times cos alpha plus 407, okay, minus sine alpha plus 47 times sine 2 alpha plus 283 is equal to cos alpha plus 30. I'm gonna just squeeze it in there. Okay, and yeah, so basically we're proving that the right hand side is equal to the left hand side, and that is 5 marks. Okay, so yeah, I'm definitely going to look at the left hand side and make it equal to the right hand side. What do we see here? First of all, I see I have cos, sine, right? And if the angles were the same, really, I could just write there that cos is 2 theta plus what, or whatever. Okay, but the angles, I see they're not the same. So here I have 2 alpha and 77. Here I have 2 alpha and 283 degrees. There I have alpha and 407, and I have alpha and 47. Okay, so let's see, what can we do? So cos, I'm going to leave the 2 alpha plus 77 because I already have an acute angle. I'm not going to reduce that. But the second one, I have cos alpha plus 407. Where is 407 in the Cartesian plane? So we have 0 degrees, 90, 180, 270, 360. Okay, so these are multiples of 9. 9, 18, 27, 36. If we go plus 90 again, we're going to get 450. Okay, so I know that 407 will lie in this quadrant. So what can I reduce it to? If I say 407 minus 36, what will I get? Minus 360. What did I say? 36. I get 47 degrees. So I know that I can reduce, first of all, cos is positive in the first quadrant, and I can reduce 407 to 47. Okay, so I have alpha plus 47. Okay, so that is working out. I'm just going to erase this to make space. Alrighty, and then I have minus. Okay, so I'm just going to, I want to start with this because I can see that's where my double angle is. Okay, now I have sine 2 alpha. I want to keep the 2 alphas to come first. So I have sine 2 alpha, but I have 283. Where is 283? 283, okay, this is 27. No, yo, that's 180. That's 180, and that's 217. Okay, so I know, and then I have 360. So I know then I'm in the fourth quadrant. 283 is in the fourth quadrant. I almost said it's in the third. So it's in the fourth quadrant, where 360 minus theta is, when we want to reduce. So if I were to say 360 then minus 283, what? I'm working with angle 77. So I have there plus 77. But guys, sine is negative in the fourth quadrant. So I have a negative there. Okay? Let's just remove that. And then we can deal with sine alpha 47 plus 47. Okay, so we have sine times sine alpha plus 47. Okay, so now I have similar angles. I have 2 alpha 77, 2 alpha 77, alpha 47. Hello. So now I can get my cos sine sine. So what is the double? Okay, it's not really a double angle here, but if I have cos and sine sine, I take the angle, okay, 2 alpha plus 77, and then I had to simplify it. Right, let me simplify the previous one. So I have cos 2 alpha plus 77, cos alpha plus 47. Now these two will turn into a plus. Then I have a sine 2 alpha plus 77 and sine alpha plus 47. Okay, just had to put that plus over there. So again, I have a cos plus sine. So and if we have a plus there, we're going to have a minus here. So what am I subtracting? I'm subtracting. So 2 alpha plus 77 degrees minus alpha plus 47 degrees. Okay, I hope you are following me. If you aren't, please just comment below and I'll try to explain. So 2 alpha, and I can see it's minus alpha there, and I have 77 minus 47. Okay, so 2 alpha minus alpha, that's just alpha. 77 minus 47, well, 7 minus 7 is 0, 7 minus 4 is 3. So I have 30 degrees. And is that what the right hand side is? Yes, the right hand side is cos alpha plus 30. Okay, so far so good. Last question, 5.5. So we need to solve for alpha plus beta. Okay, so we have sine 3 alpha minus beta is equal to 1 over root 2. And they tell us that 3 alpha minus beta has to be in between 90 and 270. So the solution must either be in the second quadrant or the third quadrant. Okay, and then we have tan 2 alpha plus beta is equal to 1 over root 3. Okay, if 2 alpha plus beta, again, second or third quadrant. So what I would do, I would draw my triangle. Let's use a different pen color. So sine, I know it's opposite over hypotenuse, so it's y over r. So if I were to draw, and I mean, it's shown as being positive over here, so I can't really use the second quadrant because y is positive but x is negative. Okay, so I need to use the third quadrant, okay, where both of them are negative, which both can give a positive answer. Okay, so if I have my triangle, I know that my x will be a certain value, but it will be negative, and I know my y is also negative. In this case, it's negative 1. Okay, so then I have root 2 as my hypotenuse. All right, so now I need to get what x is, and I hope you've seen that this is a special angle. If you were to say that one, 2, you should know that it's 45, but if you don't know, it's okay. You can always calculate it. Okay, so sine 1 over root 2. Okay, so that's 45. But, I mean, 45 degrees, that would be in the first quadrant. Okay, and we're not dealing with the first quadrant at this point. We need the third quadrant's value. Okay, so in this case then, I know that 45 degrees basically means whatever x value I have, the y value will also be the same. Okay, so I know in this case that x is also going to be minus 1. All right, my eraser is doing the most here. Okay, so that would be minus 1. Or, you know, if you didn't know with 45 degrees that your values for and x are the same, you could have said that r squared is equal to y squared plus x squared. We already know that y is negative 1 squared, and we already know that r is root 2 squared. So that is 2 is equal to 1 plus x squared. If I take 1 to the other side, x squared is equal to 1. Therefore, x is equal to negative or positive 1. But in this case, we are choosing the negative 1. Okay, that was a quicker way of doing it. Whichever way is understandable for you. All right. So in that case, what would I take as my, if I solve for sine? Okay, so basically, let me just erase this out so that we solve for our angle. So I have 3 alpha minus beta is equal to that sine, and my y value, we said it's negative 1, and we have root 2. Okay, so we can get that value. So 3 alpha minus beta is equal to, just going to put a negative there. Okay, negative 45. Okay, if I'm going to add 180 to it, I get 135. Okay, so we have our first equation, and then we're going to deal with tan. What did they say about tan? They said tan 2 alpha plus beta is equal to 1 over root 3. Okay, and then, yeah, I think same story. All right, it has to be in between the domain of 90 and 270. Okay, and we know that tan is y over x. Okay, so what is the y value? The y value would, in this case, if I choose this quadrant, the y value would be positive, but the x value would be negative. So I'm not gonna focus on that quadrant, but I'd rather look at the third quadrant. So in this case, y is negative, so I would have negative 1, and x is also negative, so I'll have negative root 3. Okay, so let's go work out what 2 alpha plus beta is. So I have negative 1 over negative root 3. Okay, so tan negative 1, but it will cancel the negatives. So what are we going to do? So 30, and I'm going to add 180 degrees to it. Okay, so I get 210. 210. So 2 alpha plus beta is equal to 210 degrees. So now this is my second equation. So with my first equation, I am just going to write everything in terms of beta. So if I take beta this side, it will be positive. Then I have 3 alpha minus 135. Okay, so then I have beta there. So basically, I will substitute beta into equation 2. Okay, So I have 2 alpha plus beta. So I'll say plus 3 alpha minus 135 degrees, and that is equal to 210. Okay, so 2 alpha plus 3 alpha, that's 5 alpha. If I take 210 and I add 135, I get 345. So now alpha is equal to 69 degrees. Now let's check. They said 3 alpha minus beta has to be within this domain. So 3 alpha, so 69 times 3 is 207. 207 minus beta. Okay, I haven't solved for beta yet. My goodness, I'm getting ahead of myself. So beta is equal to 3 alpha. So 3 alpha, 3 times 69 minus 135. Ooh. Okay, let's see. So 3 times 69 minus 135. So that is 72. So beta is 72. Now let's check. So the condition is 3 alpha minus beta. So 3 alpha minus beta must be, yes, I get 135. So it's in the second quadrant. And then the second condition is 2 alpha minus or plus beta. Beta is 72. And that's in the third quadrant. Oh, duh, obviously 210 and 135. Blonde moment there, but yes, at least it works. Okay, we have our alpha at 69 degrees, we have beta 72 degrees, and we are done with question 5. Thank you for tuning in. Hello everyone and welcome back to MV Tutors. It's me, Tsolo, continuing with you for question 6. Continuing with you, not for you. Alright, so please don't forget to like our videos and subscribe to our channel. Okay, let's get to question 6. So it says in the diagram below, the graph of f of x is equal to 2 cos x. What happened there? The amplitude has been doubled. So instead of the maximum and minimum values of the cos function being 1 and negative 1, we're going to get 2 and negative 2. All right, and we have it for the domain negative 90 to 180 degrees. Cool. So now 6.1, it says draw the graph of g of x. So what is g of x? G of x is negative tan 3 over 2x. Okay, for that interval. So in this, at this point here, if it's a negative tan, so tan normally does this. Sorry, tan normally does that. So if it's negative, no, it doesn't. My goodness. What did I just do? Yeah. So it's gonna look the other way. Okay. But we're gonna use our calculators here. Okay, we're gonna go to the table function. I think on your calculator, if you're not using this one, it will be option 3. And we're going to write the equation as it is. Okay, we don't want to complicate our lives because we can see here the period has changed. So yeah, we don't want to think too much. We just want to put it in the calculator and hope for the best. So we are starting at negative 90. And we are ending at 180. And we're going in steps of 30 degrees. Okay, yeah. So at negative 90 degrees, we have negative 1. Okay, negative 1. At 60, we have our asymptote. Okay, hence we have an error. At negative 30, we have 1. All right. 0 degrees, we have 0. Okay, at 30, we have negative 1. All right, at 60, we have an error, so that's another asymptote. And then 90, we have 1. At 120 we have 0. At 150 we have -1. I'm sure at this point you're like, what is going on? 180 we have an error, so we have another asymptote. Okay, so basically if you were to look at this, your graph does something like that. Okay, all right, and that is G. Cool. So what do they want us to indicate? Clearly show all asymptotes. Okay, intercepts with the x's. So yeah, I mean we have 0 and 0, and then we have what, 120 and 0. What other intercept do we have? None. Oh my goodness, I forgot to draw this last portion here. Okay, so I think we're good with the graph. Yeah, now 6.2, we need to determine the period of G. Remember the period equation? Okay, period for for tan, your period is 180 degrees. All right, and here the period has changed. Now we have a period of, let's see, we have a period of 120 degrees. Okay, we're going to calculate it. But basically a period is how long or over how many degrees does it take to complete a full curve. Okay, for the sine graph and the cos graph we have 360. So now for the tan graph we have 180. That is the normal period. So you'll take 180 and you're going to divide it by the coefficient of x. In this case, the coefficient of x is 3/2. So we're going to run back to our calculators, go to the first mode, and we're going to say 180 divided by 3 divided by 2, and we get 120. Okay, you could have calculated it, or you could have looked here on the graph. So between your asymptotes, okay, you have 60 here, 60 there, so that's 120 degrees. That is your period, or you could have calculated it. Okay, I think that's what, 1 mark. 2. Okay, at least they gave 2. Now it says 6.3. Write down the values of x in the interval for which f is decreasing. So f is our original function. Where is f decreasing, guys? So this is where it's flat, right? Turning point, gradient is 0, flat. Nothing, no decreasing, no increasing. Even at 180, again, gradient is 0, flat. Okay, so where is it decreasing? Here we see it is increasing. Over this section over here, that's where it is decreasing. So we will say that x, what values? So it starts decreasing after 0 degrees. So we only put x is bigger than, we don't put the equal sign, please. Okay, and then it decreases until it reaches just before 180 degrees. So that's it. And then 6.4, use the graph of G to determine which values of x. Okay, which values of x, oh, what did I do now? Okay, bigger and equal to 1 for that interval. Okay, so what are they saying? Use the graph of G to determine which values of x will the values of y be bigger and equal to 1. Okay, we're gonna look at the graph. Okay, and it's saying, use a different colored pen. Which values of x, will the graph have values of y that are bigger and equal to 1? So let's put 1 as our border. Okay, so I can see at -30, yes. Okay, so between, so x can't be -60, but it's after -60 until it reaches -30, and there we include it because it said bigger and equal to 1. So you can see the y values of G here are bigger and equal to 1. Okay, Then we go to the other section. Here it's smaller than 1. Now we go to this section over here. Okay, we can see that x is bigger than 60, and then we have 90 degrees here. Okay, and we are including that 90 degrees because there it is equal to 1, and that is our solution. Wow, 4 marks. Did I do too little? I don't know, but we're using the graph, right? We're determining the values of x for which the graph of g of x is bigger and equal to 1. So that is our solution. So x is in between. So x is bigger than negative 60. Okay, and smaller and equal to negative 30. And again, x is bigger than 60. Okay, it can't touch 60. But then smaller and equal to 90. Or you could have said x is an element of negative 60 to negative 30, 60 to 90. Okay, I hope it makes sense. Is there another one? Nope, I can't see. If you can see any other solution, comment down below. Now it says the function h is obtained by translating the graph of g 30 degrees to the right. Remember, if you're going to the right, negative. If you're going to the left, positive. So basically the graph of g of x, it is negative 10 3 over 2 x. Okay, and then the graph of h is when we take g and shift it to the right. So we still have negative 10, amplitude of negative 1. We still have our coefficient 3 over 2, but the x, whenever you have a horizontal shift, you'll have your x with something in brackets. Okay, and because we're moving to the right, it has to be negative 30 degrees. Okay, so that's a horizontal shift. Horizontal shift. Okay, that's a change in your period. Okay, this is what happens to your amplitude. And if you had plus or minus q, that would be a vertical shift. Okay. Ooh, shift. Now I write another word. Okay, but anyway, this is h of x, and that's where we conclude question 6. Thank you. Hello everyone, and welcome back to MB Tutors. I'm Tsolo, and I'll be looking at question 7 with you guys. Please don't forget to like our videos and subscribe to our channel, and please tell your fellow classmates that there is a YouTube channel where we go through past papers, okay, in preparation for the November exam. Okay, now we're doing question 7. Okay, it says in the diagram below, AB is a pole anchored by 2 cables at C and D. All right, B, C, and D are on the same, or are in the same horizontal plane, so they're like sort of like on the floor. All right, the height of the pole is h, and the angle of elevation from C to the top of the pole is a. Oh, to the top of the pole A is theta, and then we have that angle A in between C and D is 2 theta, and AC is equal to AD. With this question, guys, I really love sectioning it and dealing with each triangle separately. What do I mean by that? So I can see here 3 triangles. The first one, okay, is where I have AB, H, and then I have C, and I have my angle there. Okay, so that's ABC, and I can also see ABD. A, B, D. I don't have an angle for D, but I know that AC is equal to AD. And then the third triangle that I'm seeing here is ADC. Okay, I know these two angles, or these two lengths are the same, so these two angles are also the same, whatever they are. And then I have 2 theta. It makes life a little bit simple for me. I don't know for you. Now let's read the question. It says, determine CD, the distance between the 2 anchors in terms of age. Okay. So what are we going to do? The triangle with the most information that has age will be ABC. But before I even get there, I want to get DC, and what rings in my mind as I look at triangle ADC is the cos rule. What is the cos rule? Well, if you have forgotten it, let's go to the formula sheet. Where is the cos rule? Now I can't see it. Guys. Oh, there it is. There it is. So A squared, blah, blah, blah. So I will say DC squared is equal to AD squared plus AC squared. And then what do? We subtract 2 times AD times AC, and then we say cos A. Okay, in this case, yes, it is cos A. So that is the cos rule. Yeah. Now, let's see what we can do. Okay, so somewhere in your sheet, you will focus on, okay, so this is the formula, right? But you would write there, I'm just writing things all over the place. So triangle ABC, I know that I want cos, right? Because, yeah, there's no sign here. So I would say, no, I am going to choose sine because I need h. So sine theta, and I need the hypotenuse as well, is equal to h over AC. Okay, so now AC is equal to h over sine theta. So I took AC this side and I divided by sine theta. So it's going to be over h over sine theta. And I know that AC is equal to AD. Got it? Cool. So now we can go and substitute it in this main formula. So I know that AC, or rather AD, is h over sine theta, and that is squared. I know AC is h over sine theta, and that is squared, minus 2 h over sine theta, h over sine theta, cos 2 alpha. Okay, so now we're going to be solving, guys. So I have 2 times h squared over sine squared theta. Okay, I hope you see it, because h squared over sine squared plus h squared over sine squared is 2h squared over sine squared theta. Then we have minus 2, again, h squared over sine squared theta times cos 2 theta. All right, so if I take out 2h squared over sine squared theta, I'll be left with 1 minus cos 2 theta. Remember, there are 3 options for the double angle of cos, and because I'm seeing sine squared here, I'm going to go with the sine squared option, okay, so that I don't complicate my life. So I have 2, I'm just going to put it together, sine squared theta, 1 minus. So I have 1 minus 2. You can go check in the formula sheet if you forgot, but cos 2 theta is equal to 1 minus 2 sine squared theta. And then if I simplify that, I still have 2h squared over sine squared theta, 1 minus 1 plus 2 sine squared theta. Can I just cancel already? So 1 minus 1, that's 0, so I'm left with 2 sine squared theta. And I'm a happy girl because things can start to cancel out. So the sine squared will cancel with the sine squared. Then I'm left with 4h squared. Oh, we're not done. We're not done. This is DC squared. They wanted CD, DC. Let's just call it CD. So now CD squared, if I root both sides, I will get that CD. I'm not going to say plus or minus because this is a length. It has to be plus, okay? So I'm going to be left with 2H. So CD is 2H. I was going to say, if you look at the sketch, does it make sense? But it's not drawn to scale, so, but it kind of does. I mean, if AB is H, then CD can be 2H, right? And that's where we end it for this session. So we're done with question 7. Yeah, thank you for tuning in. Don't forget to like our videos and subscribe to our channel. Hello everyone and welcome back to MV Tutors. I'm Tolo and I'll be looking at question 8 with you guys. Please don't forget to like our videos and subscribe to our channel. And also don't forget to share this information with your classmates. We've been getting requests for the past paper. Unfortunately, yeah, we're at the moment, we don't have a link to share it with you, but if you want to get it, please email us at mananaventures@gmail.com. All right, and then we'll send it to you. We only have the English version. Someone was asking for the Afrikaans. Yeah, anyway, our tenant Google has been providing us with the papers, so I don't know. I don't have any other copy other than this one, English copy. Okay. Anyway, let's get to the questions. All right, question 8. It says, in the diagram below, points P, Q, R, and S are points on a circle with center O. As soon as I hear center O, I get excited because I'm already thinking angle at the center is twice that of the angle at the circumference, or something along those lines. Okay, and I know I have radiuses or radii that are equal in length, obviously. So yeah, UV is a tangent to the circle. When I hear tangent, I'm thinking a line from the center to the tangent is perpendicular to the tangent line. I'm thinking tan chord theorem. You know, my mind is already getting busy. Okay, PR and OS intersect at T, and RQ is produced to W. So PQW, so the angle at Q is 106, and SP is equal to SR. When I hear that, I think isosceles triangles, equal lengths, equal angles, blah, blah, blah. Okay, so yeah, so when I get this kind of information already, I'm thinking tan chord theorem. I know that P5, if I look for a triangle in here, P5 will be equal to R3, P1 and 2 would be equal to, which triangle am I looking at? They'll equal to R2 if ever we were asked. I know that O1 is twice the angle at S, so this is half O1. I know that these are angles in a straight line, so I'll just take out my calculator and just say 180 minus 106, you know, but obviously this is when you have time, because sometimes you just want to get straight to the question. And I know that P4 is equal to R3, and we established that R3 is equal to P5. All right, what else? I don't know, let's just go to the question and stop wasting time. All right, now 8.1.1. Okay, we need to calculate with reasons the size of S if we look at S in between P and R. So where's P? There is P. Let me use a different colored pen. So normally with Euclidean geometry, it's always nice if you have different colored pens. Okay, so P, and then we have S, and then we have R. So this is S that we're looking for. We already marked that S, angle at the circumference, will be half angle at the center. Okay, remember this rule. You have an angle at the center, and you have your chord here. You either have a situation like this, or you have a situation where you have a reflex angle. There's your reflex angle. it will be equal to that angle. So they're like on the same side. Okay, cool. So S will be equal to half of O1. But now what is O1? Let us see if we can solve it. Okay, we need to go determine what O1 is, or what S is, if you can find it. Oh, actually, there's another way of getting it. Yes, S is half of O1, but I see something else, which is much quicker. Okay, you see we have a cyclic quad, and we have there an external angle to the cyclic quad, right? So that makes our life a little bit easy. So S, let me just say P, SR is equal to 106, and that is due to external angle of a triangle. Okay, external angle, just write it down, external angle of cyclic quad. Did I say triangle? External angle of a cyclic quad. Okay, these are just 2 marks, guys. And then 8.1.2, we're looking for R3. So there's R3, and we said R3 is equal to P4, which is equal to P5. But we can see that actually R3 is equal to P4 because equal sides yield equal angles. And why is that? It's because we have an isosceles. This is the way English comes in. We have an isosceles, isosceles triangle. Okay, so we know that in our triangle we already have 106, right? So we need to know what those 2 angles are. So basically, if I'm looking for R3, because R3 is equal to P4, I'm just going to say 2 times R3 plus 106 is equal to 180 degrees, and that is due to sum of angles in a triangle. All right, so let us get what R3 is. So 180 minus 106, I did work it out, it's 74. Yeah, it's 74. Okay, so we have 2R3 is equal to 74. Let's see, can I link it to it somehow? I can't see it, let me not waste time. So R3 is equal to 74 divided by 2. Okay, and that is 37 degrees. Okay, and that is equal to P4, if ever it is asked, right? And now we get to 8.1.3. Now we need P5. So P5 is equal to P4, which is equal to R3. So P5 is equal to 37 degrees, and that is the tan chord theorem. All right, 8.1.4. This is going quickly. Now O1, So I know that O1 is twice S, right? And S, P, S, R. Sorry about that. I felt it coming and I thought I could somehow finish this question before sneezing. All right, and basically angle at center. Angle at center, you can leave it at that, or you can explain the angle at the center is twice the angle at the circumference, or rather the angle subtended at the center is twice the angle subtended by the same chord at the circumference, but angle at center will work. Okay, and we know that S was 106, right? So 106 times 2. Okay, 106 times 2 is 212. There we go. And then 8.1.5 P3. Okay, so let's go back to drawing. What is P? Where is P3? Oh, there is P3. Okay. So what I can see, I hope you can see it with me. We have again an isosceles triangle, that is the radius. Okay. It's also the radius. Do we have R2? No, we haven't calculated it. So we're looking for P3, and we know that P3 is equal to R2, equal lengths, equal angles in an isosceles triangle, right? And then, what do we know? We know that, sorry, let me just switch things off so that we do not get disturbed. Okay, I know O1, I just solved it, it is 212, okay? So, angles, or rather revolutionary angles equal to 360, right? Angles in a revolution are equal to 360. So if I get this angle over here, I can then use angles in a triangle, or sum of angles in a triangle equal to 180, and then blah blah blah. So let us do that. So getting back to that, so O1 plus, I'm gonna name it O2. We don't have a term or a name for it. Okay, I'm just gonna say O2. So O1 plus O2 is equal to 360, right? Because of sum of angles in a revolution. Okay, we know that O1 is 212, so O2 will be 360 minus 212, and we have that as 148. Okay, then I know that P3, which is what we're looking for, is equal to R2. Okay, that's because we have an isosceles triangle. Okay, triangle POR. Okay, equal sides, equal angles. Okay, so now I know that O2 plus 2 times PR is equal to 180. We are doing so much for 2 marks. Sum of angles in a triangle. So O2 is 148. So 2 times P3 is 180 minus 148. So P3 is 180 minus 148 all over 2. I'm just going to solve it. So I have 180 minus the answer, which was 148, divided by 2, and we have P3 is equal to 16. Sorry guys if you're hearing the noise outside. Kids are playing. This is the only time to record, so bear with me. Alright, now we are done with 8.1. Alright. Thank you for those guys who comment and who do say, Tulu, you made a mistake, this might be wrong, blah blah blah. I'm rushing through it because I need to fetch my son in 10 minutes. So if I made a mistake somewhere, guys, please correct the lady here. Alright, now we get to 8.2. In the diagram below, A, B, C, D, and E are points on a circle centered O. Again, I'm very excited when I hear center. Why? Because I know there's angle at the center and there are also angles at the circumference somewhere. Okay, let me see. yeah, so this angle at the center would be equal, this is the chord, would be equal to D1 over there. And then if I look at this angle O1, using chord CD, I would get A2 being half of A1. CD also subtends E, so X, so basically this would be X. And because I have the same length, BC also K. All right, so yeah, center O. Now let's continue reading. AC, OC, and ED are drawn. So AC, okay, it's this long one. OC, and ED are drawn. All right. Chords BC is equal to CD. Okay, and then CED is equal to X. All right, cool. Now, okay, now 8.2.1, determine with reasons two other angles which are equal to X. Okay, we got it. So A2 is equal to X. We'll get to the reasons now. And also A1 is equal to X. So why is A2 equal to X? Angles subtended by same chord. Okay, and that chord is CD. Okay, angles subtended by the same chord are equal. And then A1 is also equal to X because we have chords of same length. Ooh, my handwriting is incredible. So BC is equal to CD. All right, 8.2.2. Determine A, B, C in terms of X. So we have A, B, C. So we're looking for B in terms of X. Okay, what do I have here? If I have a cyclic chord over here. No? So let's see if we can do something with the cyclic chord. So I know I'm looking for B. B will be equal to D1, right? Because opposite angles in a cyclic chord are equal. So B will be equal to D1. Okay, and D1 we said that is equal to this O here. All right, so I'm gonna call that O2. Okay, let's say this is O1. I'm gonna call that O2. Okay, if you're gonna name things in your paper, please just indicate it so that your marker is aware of what is happening and what you're doing. Or you could say, rather, instead of using O2, as in, yeah, let me not do that. Let me just say, this is A, O, C. That's better, né? And this one would be D, O, C. Okay, I think this is better than putting your own things. Please apply to the previous question as well. Alrighty, so I'm looking for B in terms of X. So I know O1, guys, or rather I can get O1, or rather DOC. So DOC is equal to twice A1. No, A1 or A2 doesn't matter, but it's equal. I'm looking at A2 specifically because, yes, so this angle and that angle, yeah. So basically, that'll be angle at center is twice the angle at the circumferences when they are subtended by the same chord, which is CD in this case. So I know A2 is equal to X, therefore DOC will be equal to 2X, right? Great. Now, if I know DOC, then I can get AOC because DOC plus AOC, they're both equal to 180, okay? And that is sum of angles on a straight line. Okay, I know DOC, which is 2X, therefore AOC is equal to 180 minus 2x. All right. Yeah. So, what am I doing? All right. So D1, D1 is half, right? D1 is half of AOC. D1 is equal to half of AOC. So basically 180 minus 2x over 2. So I have 90 minus x. And I know that D1 is equal to B, finally. So D1 is equal to A, BC, which is equal to 90 minus x. And therefore, that's because opposite angles in cyclic quad are equal. Okay, we got it. There's another way of solving it. Again, please guys, interact, comment, write down below so that, you know, if you have an alternative solution, we can, you can present it to other students as well. But what I can tell you, a tip, because my husband did it in another way, AD is a, what do you call this? A diameter, and angle subtended by the diameter is 90 degrees. Okay, so you can work something from there. Now 8.2.3. Okay, prove that AB is parallel to CO. Okay, we've done a whole lot of markups here. Let's just see, what are we dealing with? Prove that AB, where is AB? Okay, this is AB, is parallel to CO. Okay, if you want to prove that lines are parallel, you can prove it in three ways. Firstly, you can show that angles are alternating. Okay, so therefore I'd have to show that A1 is equal to C2, or we'd have to show that angles are corresponding. So I'd have to prove that A1 plus A2 is equal to DOC, or I'd have to prove co-interior angles, right? So therefore I would have to show that A1 plus 2 plus B is equal to 180. And we can actually use either co-interior or corresponding, because we have A1 plus A2, which is basically 2x, and we solved for B, right? But anyway, I want to go to the corresponding. You guys can look at co-interior angles. So I have to show that A1 plus A2, okay, I am out of time. A1 plus A2 is equal to 2x, right? We already solved it. And then O1, which I said is DOC, is equal to 2x. Okay, we also solved it previously. So therefore, AB is parallel to CO. And why is that? It's because we have corresponding angles. Okay, and we are done. Guys, don't forget to like our video, subscribe to our channel. You know the drill. Let me fetch my son. Hello everyone, and welcome back to MV Tutors. I am Tulu, and I will be doing question 9 with you guys. Yeah, there I was clicking on the keyboard. Okay, so I hope you are doing well. Let's finish this paper off. It's taking a bit of a while, and I know you guys are preparing for physics that you're going to be writing, well, in Gauteng at least, on Friday and Monday. Okay, so in the diagram below, BOA is the diameter of the circle centered at O. So I know that OB is equal to OA, right? As I read these things, I just write down so that I don't forget. And they are all radii, right? Okay. And then BE is a tangent to the circle at B. Okay, so if it's a tangent, I mean, you can always extrapolate this line. But basically, if you have a tangent and a triangle that has all its corners touching the circumference of the circle, then we can do things, right? By the way, please don't forget to like our videos, subscribe to our channel, you know the drill. Alright, so I would know that B2 would be equal to A. Okay, so these are just notes that I'm writing for myself as I'm reading the question, and that would be the tan chord theorem. Okay, and then what else do they tell us? And EA cuts the circle at D. So this is A, where's E? Okay, EA cuts the circle at D. Okay, oh, another thing about the diameter, guys. If you have a chord that's a diameter, you know that the angle it subtends is 90 degrees. So I know that D1 is equal to 90 degree. Why? Well, the diameter is the chord. If you want to explain or expand on that, you just say the angle subtended by a diameter is 90 degrees. Okay. What else do we know? We know that F is the midpoint of AD. So this is D and that's A. So F is the midpoint. So I know that DF is equal to FA. Okay? Yeah. And I think we can start answering questions. Alright, 9.1. It says prove giving reasons that 9.1.1 OBEF is a cyclic quad. Okay, now let's go and check out where OBEF is. So O, B, E, and F. So basically you would have a circle. Okay, they want you to imagine that this is a cyclic quad. Okay, so you have a circle like that and there is a cyclic quad, and we need to prove that indeed OBEF is a cyclic quad. So what do? When you want to prove that something is a cyclic quad, you can prove it in one of three ways, okay? Either you show that the angles subtended by the same chord are equal, or you show that the external angle of a cyclic quad is equal to the interior opposite angle, or you show that opposite angles in a cyclic quad are supplementary. Okay, when you add them, equal to 180 degrees. So we're going to have a look at our cyclic quad here and see what would work. Okay, so of these three options, which one would work basically? So let's have a look. Oh, another thing about this that we have, if you have a line from the center and then it goes all the way and there's a tangent line, you know that it is 90 degrees. Okay, so basically B1 plus B2 is equal to 90 degrees. These are things that you must just note. So whenever you're doing Euclidean geometry, please have different colored pens just so that you can align yourself. Okay, so it's equal to 90 degrees because the radius is perpendicular to a tangent line. Okay, so yeah, let us see, what do we have? So with the first one, same chord, I don't see it subtending, so I'm not going to go with the first option here. But if I look external angle, so this would be O1. If I can prove that O1 is equal to E, I don't really have information about O1 or E. Okay, but that's the external angle that I can see. I also see F1. Alright, F1, external angle, interior opposite angle. So if I can prove F1 is 90, I don't know how. Oh, yes we can. Yes we can. So if you have a line that meets a chord, then you know that it's 90 degrees. Okay, so we can definitely go with that, right? Let's see the last one though. Opposite angles, yeah, so again, E, I would have to know what E is. I would have to know what O2 is. I don't know it. And I know B1 and B2 is 90. F2, I would have to prove somehow that F2 is 90. But yeah, let's go with what we've just discovered. Okay, so we're gonna go with F1 being equal to B1 plus B2. All right, so F1 is equal to 90 degrees. And that is because a line from center to chord. Yeah, from center to chord. Line from center to chord is perpendicular to the chord. Okay, it's perpendicular to the chord. Okay, and it's also a bisector. Okay, yes, it is a bisector because FD is equal to FA. All right, so yeah, line from center to chord is perpendicular to chord, and it also bisects. Okay, now that we know F1 is 90, it's actually an external angle to the cyclic quad. So now F1 is equal to, firstly we must say B1 plus B2, but there it is, we wrote it down, right? So you can just take it there. This is the first thing you're gonna write. That's the second thing you're gonna write. And then thirdly, we can get there. F1 is equal to B1 plus B2. Okay, and they're both equal to 90. Why? Because external angle of cyclic quad is equal to the internal or interior opposite angle. Interior opposite angle. Let's stick with that. All right. When I looked at this question a few days ago, I wrote it differently. Now I'm wondering what I wrote previously. Okay, 9.1.2. So triangle ADB is similar to triangle. Okay, so the way they wrote it, triangle ADB is similar to triangle BDE. By the way, guys, thank you so much for commenting, especially showing how you would have worked out a certain question. It really helps those who are looking, just in case they don't get what I did. They can have a look at what you are commenting on and suggesting. That's really great. I love that interaction. So thank you. So now we need to show that triangle ADB is similar to triangle BDE. Let's go and highlight those. Okay, triangle ADB. So ADB. So it's basically this big one over here. Okay, ADB as well as BDE. Okay, let's go with pink. Okay, the way they wrote it out is very important because it shows us how or what we should focus on. Okay, so in this case, because we don't have lengths, I'm not going to use the proportionality or proportions of them. Okay, proportion meaning AD over BD is equal to DB over DE, which is equal to AB over BE. We're not going to use that because we don't have any length. What we do have is angles. So I need to go show that angle A is equal to B. All right. I need to show that D is equal to D. All right. And I also need to show that B, angle B, is equal to angle E. So let's start with A being equal. So I need to show that A is equal to B2, and I think we already wrote it down, right? So we're saying that yes, A is equal to B2. Why? Tan chord theorem. Okay, cool. Now D is equal to D. Okay, so we know that D1 is 90 degrees there, okay, because the diameter is equal to the diameter by subtends 90 degrees, right? Yeah, an angle of 90 degrees. So D1 is equal to 90. We already wrote that down. We said that diameter is the chord, right? And because of such, we can say D2 is also 90 degrees. Why? Because sum of angles on a straight line. Okay, therefore, D1 is equal to D2. Alright, so the last angle, we've shown that A is equal to B2. We've shown that D1 is equal to D2. Now the last one, E. Okay, E would be equal to, okay, let's see. E can be equal to B1. Okay, so once you've reached here, you can then conclude that because you've solved two other angles, that the last one will be equal because, you know, sum of angles in a triangle. But if you did wanted to show how E can be equal to B1, you can stick around, otherwise you can fast forward. So let's show how is E equal to B1. Let's prove this one. E is equal to B1. Okay. One thing I've realized, I don't know if you remember the midpoint theorem. Okay, so the midpoint theorem says if you have a line, let's say you have a triangle, né? And then you have a line in the triangle which bisects two sides of a triangle. Like F here bisects DA and O bisects AB, okay? That line will be parallel to the third line of a triangle. Okay, let me just do it like this. So you have a triangle, then you have a chord. This chord bisects the two sides of a triangle. So they're saying this line, this chord here, will be parallel to the third side of the triangle, and it will be half the length of that side. So I know that FO is parallel to DB. Okay, you'd say midpoint theorem. All right, and yeah, so FO is parallel to DB, and FO is actually half of DB. Okay, and all of that is due to the midpoint theorem. So let's see how we can work it out. So from here, I know that if I put the information in, so they're parallel, I know that O1 is actually equal to B1 because like I just showed how they're parallel. So O1 is equal to B1, corresponding angles because OF is parallel to BD. All right. And then what I also realized about O1 is that if again we proved that OBEF is a cyclic quad, so O1 is an external angle, right, of the cyclic quad. An external angle of a cyclic quad is equal to the interior opposite angle, so O1 is equal to E, which is equal to B1, right? External angle of cyclic quad. Okay, so we've shown that indeed A is equal to B, D is equal to D, E is equal to B. Therefore, you can conclude that triangle ADB is similar to triangle BDE. Okay, cool, 3 marks. Did quite a lot, but it's all good. And then 9.1.3, prove that OB is a tangent to the circle passing through BDE. So the thing about trig is your question paper ends up being very busy. So looking at OB, there's OB, tangent to the circle BDE. So BDE. Okay, oh, so we have a circle here. Oh, what a circle. Okay. Okay, so there's a circle and then OB is there, it's a tangent. So how do we prove? Well, we can say that B1 is equal to, I know I've already written, yeah, so basically B1 is equal to E. We just showed it actually in the previous question. So that's all good. So B1 would be equal to E, right? And we would say that would be due to the tan chord theorem. Okay, so that was quick. And now 9.2, it says prove that OF squared is equal to AD times DE. Just make that a bit bigger. Okay. OF squared is equal to AD times DE over 4. Okay, I need this image again. Okay, cool. There it is. So OF squared. Okay, so here I'm probably going to use similarity. Okay, I get it. We've proved that, bear with me here, we've proved that this triangle here, okay, is similar to this triangle over here. So somehow, some way, we're gonna have to use that. We've already proved that. Okay, and this was 90 degrees, it's also 90 degrees, and we said that E there was equal to B1, and we showed that this B2 is equal to A, right? Yes. So we're gonna use that, and let's see what else, but let's just write what we know. So we know that triangle ADB is similar to triangle BDE. So AD over BD is equal to DB over, okay, so AD, BD, now DB, DE, which is equal to AB all over BE. Okay, so what do I have in my answer? I have OF. Okay, OF. And I have AD. Alright, so I have AD and I have DE. So I'm going to use this portion. Okay. Alrighty. So, yeah. So let's see what we can do. So I'm going to say DE multiply that side, BD multiply that side. So I have AD times DE is equal to DB squared. Okay, now let's see, what else do we know? We know that because of the midpoint theorem, we know that OF is parallel to BD, and we also know that OF is half BD. Okay, so we already spoken about it. We know that OF is equal to half of do I say doesn't matter, BD DB, same thing. Okay, so if I wanted, yes, if I want DB alone, I would say, what am I doing here? Okay. If I want DB alone, I would say that it is equal to OF times 2. Okay, but now it's not working out. Okay, so AD over BD is equal to DB over DE. I do that, that's DB squared. And I know that DB, yeah, OF is half of BD. No, yes. Why am I confusing myself? OF is half of BD. BD is twice OF. So if I put it there, I basically have, oh guys, let me just write down. I have 2 times OF, which is squared. I'm confusing myself unnecessarily. Okay, so basically that would be equal to 4 OF squared. And now we have OF squared is equal to AD times DE. It's been a long day. Just came back from church and I'm like, can we just finish this memo? Because wow, the kids need to focus on physics. And there we go. Sorry, I had a little bit of a blunt moment there. Okay, so we are done with 9.2. How many marks? 3 marks. Fair enough. Okay, now when it comes to question 10, guys, this proof, they've been asking it so many times, so I've decided I am going to show you the video where I cover it. I am not going to go through this again. But it says in the diagram below, triangle ABC is drawn. D is a point on AB and E is a point on AC such that DE is parallel to BC. Use a diagram to prove the theorem which states that AD over DB is equal to AE over EC. Here's what you're going to do. You are going to go to Google or Chrome or whatever. You're going to go to YouTube, search MV Tutors. I mean, you're already there. You're going to go to playlists. Okay? Once we are at playlists, you are going to go to grade 12 maths lessons. Okay? To view the full playlist. And once you get there, you will go to all examinable proofs, okay? And then you are gonna skip the advert that's playing over here, but you're gonna go straight down to 1 hour 27 minutes. Euclidean triangle, what did I say? Euclidean triangle theorems. Okay, and once you are there, after the ad, you are going to see the proof. Sorry guys, it is what it is. But yes, so this is where I cover it, and enjoy. You're gonna see it and you're gonna get the answer. Okay, cool. Now let's go back to the question. 10.2. Cool. So 10.2, it says in the diagram below, triangle TPQ. I think let me just copy and paste this. We have a little bit of time since I referred you to the answer before, ne? So some grace to copy this. Okay, let's just make it movable. Alright, cool. So in triangle TPQ, so there's your T, there's P, and there's Q, okay? It's drawn, and then PQ and US are produced to meet at R. UR and TQ intersect at S, okay? SU is parallel to QV. Alright, then they tell us that TU over UP is equal to 2 over 5. And then they tell us that 3QS is equal to 2ST. So I'm going to say QS and I'm going to divide by ST. Alright, that is equal to 2 over 3. Okay, or if you wanted, you could have said ST over QS is equal to 3 over 2. Okay, now calculate, given reasons, PQ over QR. Okay, so this is where you're going to use the theory that, proving the theorem here. That application is going to be in 10.2. So I'm going to I see there are two triangles here that have sides that are parallel. So I'm going to just draw them aside to make life easy for myself. Okay, firstly, I see the triangle which has T on it. Okay, I've just drawn it upright. So TUV and then TSQ. Okay, because you know that US is parallel to VQ. Then I see another one. I'm gonna draw it like this way. There's P there. Okay. So I have PVU and I have PQR, right? Where VQ is parallel to UR. Okay, what was the significance of me redrawing this? I need to use the information that they've given us into some ratios of some sort. Okay, so I know that TS or ST is 3 times something. Okay, so I'm just going to call it 3x. And I know that SQ or QS is 2 times something. So I'm going to say that. And then what do I know? I know that TU is 2 times something. So I'm just going to say 2y. And UP is 5 times something. So there's UP or PU. So 5 times y. From there, I'm going to use the proportionality theorem to see if I can eventually get PQ over QR. Alright, so where do I start? I'm going to start by saying TS over SQ is equal to TU over UV. Okay, and in this triangle we have PQ over QR is equal to PV over UV. Okay, so I see between the two, because I need to take one equation and substitute it in the other. All right, I see the common things between these two is UV. All right, but I know what TS is, right? It's 3x, SQ is 2x, TU is 2y, and UV, I don't have anything for it at the moment. So, but I'm going to just write everything in terms of UV. So the x's are going to cancel here, right? And I'm going to multiply UV that side. So I have 3UV over 2 is equal to 2y. Okay, I'm going to take 2 to the other side. So I have 4y and divide by 3. So I have UV is equal to 4y over 3. Now when I come this side, PV, so firstly, what I would do is say that I know what PU is, okay? So I know that PU is 5y. So, but PU can also be equal to PV plus UV. So that is 5y. PV, I don't know what it is. Okay, but I know what UV is. It's 4 over 3y. Okay, so then I can say PV is 5y minus 4 over 3y. Okay, at this point we can simplify it. I'm going to make 15 my common denominator. Yes, so I have 3y there. And then I have minus... No, why am I making 15 the common denominator? No, I'm just going to make 3 the common denominator. Let me not make life hard for myself. So this is like, yeah, 1 times 3 is 3, 5 times 3 is 15. Yes, and then this side I have 4y. Okay, so I have PV. Now I can substitute it back into this formula over here. Okay, so we know that PQ over QR is equal to PV over UV. PV, we know that it is 15y minus 4y all over 3. And I know that UV is 4y over 3. So we know if we have fractions, I'm going to turn that... Oh, by the way, 15y minus 4y is 11y. so I don't have to keep writing it over and over again. So multiply it. So at the end of the day, the 3's cancel, the y's cancel, and I'm left with 11 over 4. Are we officially done with the paper? Yes, we are. We are officially done. Thank you for tuning in, guys. Geez, I merged 9 and 10. I was supposed to make 2 separate videos, but it is what it is. Thank you for tuning in. All the best for those who are doing physics with the preparations. We'll see you during the memo time. Okay, don't forget to like our videos and subscribe to our channel.